Hey guys, in the last video, Intro to Inverses, we spoke about what does it mean to have an inverse. We spoke about opposites, we spoke about inverse reciprocals, we spoke about, not inverse reciprocals, we spoke about inverse properties, inverse identities, we spoke about things canceling each other out, and sort of the introduction of how to find the inverse of a function and the inverse of a graph and a table. Now, all of these thoughts and conversations about inverses and opposites made me think a little bit about what is opposite. This is a slight tangent to what we're doing, and we're going to get to this video here in a little bit, but what is the opposite? Is darkness the opposite of light? Is good the opposite of evil? Does evil exist? Does darkness exist? I don't necessarily think, according to the laws of physics and other laws of science, I don't think darkness exists. Or actually, I know darkness does not exist because darkness is actually defined as the absence of light. Darkness is not in the color spectrum, or it's not in the spectrum of the colors, so darkness is actually just the absence of having light. Cold does not exist either. When you feel cold, what you're really feeling is the lack of heat. In thermodynamics, you'll learn in chemistry or higher in science, you'll learn that there's no way to define cold. You can think of it as there being heat or lack of heat. So when you experience cold, what you're really experiencing is the lack of heat, and you express that using the word cold. Anyway, just some food for thought. I think that opposites are interestingly defined and how they go hand in hand. And you cannot have darkness without the absence of light, or you cannot have light without the absence of darkness. Anyway, it's good to think about how you can't appreciate love without, being heartbroken. You can't appreciate freedom without feeling trapped or enslaved. You can't. There's so many different things you can think about, in terms of opposites and how you can appreciate one without the other. So I hope that during this time of quarantine and being locked up, that you're truly appreciating your friends and the people that you are around, or not around as much anymore. I hope that you can appreciate just school in general. Not being at school makes you want to go back to school. Not seeing your friends makes you want to be with your friends. All of these inverse feelings that we're having in quarantine, hopefully you're able to reflect and think about the things that have come to matter most to you when they are not there or when they are absent. I, for one, I definitely miss you guys. Having you absent in my life has definitely changed the way I feel and think about my daily life. So for those loyal followers that I have, those loyal 20 YouTubers that watch my videos like 3 or 4 times, I really appreciate you guys. I miss you guys, and I can't wait to see you guys soon. Anyway, let's just get started. As I mentioned before, we spoke about in the last video how to find the inverse of a graph. We spoke about how to find the inverse of a table and how to find the inverse of a function. Now, in all these 3 scenarios, we spoke about how it is really a mirror reflection over the y equals x line. And in a mirror, the y and the x values are going to be switched. So let's go ahead and do some examples. We're going to do 4 different examples of how to find the inverse of functions. And as we progress through this video, you'll see the examples get a little bit more complicated and more challenging as we progress. So I'll provide a linear example, a quadratic, a square root example, and a cubic example. All right, let's get started. So here we have f of x equals 3x minus 2. Let's just first go ahead and change this to notation of y equals 3x minus 2. All right, so I'm going to change the f of x function, the function notation, to the y equals notation. And the first thing that I want to do is, as we spoke about earlier, we spoke about how this equal symbol will behave as the mirror, right? So the y and the x are going to switch. That's my very first step. We're going to switch the x and the y variable. And now that we have them switched, we're going to solve for y. So to solve for y, we're going to do the inverse operation. So instead of subtracting 2, we're going to add 2 to both sides. We have x plus 2 equals 3y. And then the inverse operation of here multiplying times 3 is going to be to divide by 3. We have y equals x plus 2 divided by 3. Now you can write it like this, or if you prefer to separate it, you can say y equals 1/3 x plus 2/3. Now, to write it in inverse notation, the inverse notation we're going to be using for this f of x is going to be f to the negative 1 power of x. Okay, so we're going to change this y value now into the inverse notation, and we can say that the inverse of the original function is x plus 2 over 3. And that's how we go from here to its inverse. Now, how do we check if we have found the inverse correctly? What does it mean to have an inverse of a function within a function? So what we're going to do normally is we take our answer and we plug it back into our original problem. And we're going to do that. Here, as our x value, we're going to plug in all of this. Okay, we're going to plug in all of this into the original problem for x. I'm going to separate this here in the middle. So I have y equals, or f of x equals, let's leave it in that notation, f of x equals 3 times x. Now this entire solution is going to get plugged in for x. 3 times x plus 2 over 3 minus 2. This is my original function, right? This is 3x minus 2. This is where I'm going at. Now, if I distribute this 3 in here, notice how these 3's are going to cancel each other out. And we're going to be left with f of x equals x plus 2 minus 2. These 2's are going to cancel each other out, and we're going to be left with f of x equals x, which is actually the definition of the inverse, right? Where y equals x. That's how we defined the definition of an inverse, where the y becomes the x and the x becomes the y. The right hand, right, of you facing a mirror becomes the left hand of that other person, that you looking back at you. This is how we would check our work. If you get a simple solution where y equals just x at the end, you know that you have found the correct inverse function. All right, let's do another example. Here we have a square root function. As always, we first want to separate or change this function notation to y equals notation. So we're going to write this as y equals the square root of 3 minus 5x. The second step is switch the x and y variable. So x equals the square root of 3 minus 5y. Now that we have it in this form, we are used to actually seeing the equations in y equals format. So we want to solve for y. We want to isolate this variable, leave y by itself, and move everything to the other side. Once you solve for y, that is going to be your new function. So we're going to follow PEMDAS backwards. We're going to do SADMAP. We've spoken about this before, right? I'll write it backwards here. PEMDAS backwards is SADMAP when we're solving for a variable. So here right now we have something being square rooted. There is no addition or subtraction on the outside of this function, right? There's no addition, subtraction, there's no multiplication. So we don't have to worry about these two steps actually. And now we can deal about with the square root, which is the exponent step. The opposite of square rooting something is squaring something. The inverse operation allows you to cancel this, leaving you with x squared equals 3 minus 5y. Now we're going to simplify what was inside the parentheses, right, which is this piece, and we're going to solve for y here. So we have a plus 3, a positive 3. The inverse of doing positive 3 turns into a minus 3 on both sides. We have x squared minus 3 equals negative 5y. The inverse operation of here of multiplying this negative 5 times y, this is what they're doing, is right, negative 5 times y. The inverse would be to divide by negative 5. So we divide both sides by negative 5. And you're left with y equals this notation. The numerator divided by the denominator. So I'm going to write it in the other format. I'm going to write it as, well, I have it y equals x squared minus 3 divided by negative 5. With my function inverse notation, I have the f inverse, which is f to the negative 1 power. So f inverse of x equals negative x squared minus 3 over 5. This negative right here, right, can be written in the bottom or just beside it, right next to it. Now, this is technically my answer. I want to confirm that this indeed is the inverse. So I want to plug this back into the original problem and find out if I plug all of this, right, all of this for x, in here, will I be able to get a simple solution as f of x equals x? So let's plug it in. We have f of x equals the square root of 3 minus 5 times all of this, right, which is negative of x squared minus 3 over 5. Now, this negative distributed in there makes that negative a negative, a positive 1, or a positive, right? These 5s are going to cancel, and now I have f of x equals the square root of 3. The negative and the negative become a positive. X squared minus 3. Do you see that? Do you see how this negative and negative become a positive? The 5s cancel each other out. And now if we get rid of these parentheses because there's something to distribute, or the 3 and the negative 3 are going to cancel, leaving you with f of x equals the square root of x squared. Now, since the square root and the square are inverses, we're left with f of x equals x. When we can show that y equals x, right, the reflection across that line, it means that we have found the function that is actually the inverse to the other function. So yes, this is my actual solution, is right over here. And notice, if you think about it a little bit, the inverse of square rooting is squaring. So my answer should be a square, should be the inverse of square rooting. If I start with a square, then the inverse would become a square root. Why don't you go ahead and try this example by yourself? I know it looks a little bit more complicated, but just try to do what we did in the last few steps. Okay, so I'm going to start by writing this into the y equals format. 5 halves, x plus 2 squared minus 4. And remember, I'm going to do PEMDAS backwards. So SADMAP is what I'm focusing on. I'm going to start with addition and subtraction. There is a, before I begin this process, I need to switch the x and the y value. I need to switch the x and the y. Now I'm going to start with addition and subtraction. So the opposite of subtracting 4 to move it over is to do plus 4 on both sides. I have x plus 4 equals 5 halves y plus 2 squared. The next step here in SADMAP is multiplication and division. Notice how there's multiplication and division here in front, so I need to get rid of this. So if I'm dividing, the opposite is to multiply both sides by 2. So I'm going to multiply the left side, the right side times 2, and the left side times 2. This cancels out. You're left with 2 parentheses x plus 4 equals 5 parentheses y plus 2 squared. To get rid of this times 5, the inverse is to divide by 5. And I have y plus 2 squared equals 2x plus 4 divided by 5. Now the next thing is the exponent. The exponent that I'm dealing with here is a square to the second power. The inverse of squaring is square rooting. So I'm going to square root the right side and the left side. On the right side, the square root and the square cancel, leaving you with, I'll keep it in the same side, the square root of 2x plus 4 over 5 equals y plus 2. The only thing that changed here was that the square root and the square cancel. And now I can solve for y nicely, right? I can get rid of this plus 2 and do the opposite and subtract 2. Notice how this 2 is not inside the square root anymore. It's not part of the square root, so it's going to be separate. So you have y equals the square root of 2x plus 4 over 5, and the 2 is on the outside, minus 2. I write this in inverse notation. So I have f inverse of x equals the square root of 2, open parentheses, x plus 4 over 5 minus 2. And this is my solution. Now, to check that I did it correct, I could plug this back into the original problem, right? My goal would be then to plug in this, all of this right here, plug it in for the x value, and notice how everything sort of starts canceling each other out and goes from there. I could show you this, but it would take a little bit of time. So if you want, for extra credit, you can show me this example and the next two. Prove to me in the next few examples that these inverses are actually correct. So prove that the solutions are correct and attach it to your homework, and I can give you extra points or help you replace a missing assignment. Maybe I can add points to your previous quiz and bump up your grade a little bit. So if you want to get some extra points, go ahead and prove by showing algebraically, by plugging this in here for x, that f of x is in fact equal to x. If you can show the steps to get here, then I will give you bonus points. I'll give you bonus points on your quiz or wherever it is that you're missing an assignment for this 6 weeks. All right, this next scenario. Here we have a cubic function. Now, in this cubic function, we first want to be able to switch this notation to y format. So we have y equals 2x cubed plus 1. The first step that we want to do is we want to switch the x and y values. And now we want to be able to solve for x. So remember, PEMDAS backwards. It says we start with addition and subtraction first. So SADMAP. We're going to subtract 1 on both sides. We're left with x minus 1 equals 2y to the third. The next step is multiplication and division. So since we're multiplying by 2, we're going to divide both sides by 2. We have x minus 1 over 2 equals y cubed. The next step is exponent. How do we get rid of that to the third power? Or the inverse operation of to the third is the cube root. So we're going to take the cube root of the right, cube root of the left. The cube root and the cube cancel, we have y equals the cube root of x minus 1 over 2. So the inverse function is f inverse of x. Let me write this nicer, a little bit closer. The inverse function of x is the cube root of x minus 1 over 2. Again, if you want bonus points on your last quiz, or on a missing homework assignment, or on a homework assignment that you didn't do so well on for this 6 weeks, go ahead and show me that by plugging this for x, that you get f of x equals x. If you can show all of the steps leading up to that, I will give you points on on the quizzes that we're doing this 6 weeks. All right, let's review a little bit. All right, so when you're doing the inverse of these functions, right, we're thinking about everything being a reflection over the y equals x line. This is my y equals x, right? So the point that we used as in the previous example was like 2, -2, right? Everything's being reflected across this side. This is a mirror, so everything's going to be flipped onto this side. If it's on this quadrant, it's going to get flipped to this side, right? So what ends up happening is the x and the y values ends up switching, and when you switch them, you're left with the point on the opposite side, -2, 2. So we take the same idea, and we're going to take a function, any function. Let's just say y equals 2 square root of x plus 5. Right? The first thing that we did was change the function notation to y format, which is here already in y format. The next step is to switch the x and y values. So we're going to switch the x and the y. The last step here is to solve for y using SADMAP, right? Working our way backwards. We want to get rid of this 5 first. We want to be able to get rid of that 2, and then at the end get rid of the square root. And then your final solution should be change the y equation to the notation of f inverse. The most important thing in all of this, right, I would say is understanding that we're dealing with inverses. So the inverse operation, the inverse of a square root is a square, the inverse of a cube root is a cube. So you should sort of be able to expect what your function is going to end up looking like. If I start with a quadratic, I should end up with a square root. If I start with a square root, I should end up with a quadratic. That kind of idea, right? And then, of course, plug in your solution into the original problem, and if the answers come out to f of x equals x, then you know that you have found the correct inverse. All right, guys, I hope this has helped. Don't forget to do the extra credit for these last 2 examples. Show to me that these inverses are correct, and I will give you extra points. All right, guys, calculator.